Let's look at rounding values. We'll take the same number, 0.84695, and round it to the indicated number of decimal places. We're asked to round first to one decimal place, or the nearest tenth, or you can think of this as the nearest 0.1. In the second place, to the nearest hundredth, or 0.01. 3 decimal places is rounding to the nearest thousandth, or 0.001. That's 1 divided by 1,000. And finally, to 4 decimal places, or the nearest 10,000th, 0.0001. That means we're going to round to the nearest tenth, hundredth, thousandth, or 10,000th. Let's look at that. So 0.84695 to the nearest tenth means we're only interested in whether or not this 8 stays an 8 or changes to a 9. To do that, we look at the next decimal value. If it's a value less than 5, we round down from 0.84 to 0.80. Though we'll only write 0.8. If it was a number 5 or greater, we would have rounded up to 0.9. To round to the nearest hundredth, we'll look at the second decimal place. Again, we're just going to look one spot to the right. If that value is 5 or greater, we're going to round the 4 up to a 5. So we get 0.85. In other words, we're rounding up from 0.846 to 0.85. Now 3 decimal places. We have 0.84695. All right, we're interested in rounding this 6 either to 60 or 70. So up or down depending on what's in the spot to the right. 9 is clearly 5 or greater, so we're going to round up to 0.847. And finally, rounding to the nearest 10,000th. We're interested in the 4th decimal place, or the 10,000th place, and we're only going to look one decimal place to the right to consider whether that 9 will stay a 9 or round up to a 10. Of course, if it rounds up to a 10, then that 69 becomes 70. It increases the count to the left. We do in fact round up due to this 5, so we have a value of 0.8470. It's important that I include the 0 because we've been asked to round to the nearest 10,000th, so I want to include the 10,000th digit in here as well.